Hi there. All right, 2.3, Section D. Yes, the last installment of Section 2.3, dividing fractions. It's almost identical to multiplying fractions that you just did previously. However, there's one small catch in between here. So, as always, anytime you see a mixed number, you must change it to an improper fraction. This is where I'm sure you remember from your summer packet from all that work in 6th grade too that you did with dividing fractions, that keep, switch, flip, kind of like what we did with subtracting integers. But what this means is that you're going to always keep the first fraction the same. You never mess with your starting number. Switch the multiplication sign to division.
Ooh, that's backwards. I'll have to fix it. It should be switched to
Oh,
division
you're
sign to
right.
multiplication. On your copy, I will have that
It will
fixed.
be fixed, but let's just fast forward. All right. Flip the second fraction that follows. Take the reciprocal. Reciprocal just means flip the fraction over. So 2/3 would be 3/2. Don't you love that fly? It keeps going on the screen. Okay. You may cross cancel again at this point, or multiply the numerators straight across the top and multiply the denominators straight across the bottom, and then simplify in the end if you didn't cross cancel. Just like with multiplication, if the signs are the same, the answer is positive. If the signs are different, the answer is negative. And as always, use estimation to make sure your answer is sensible. All right, our first example, -1/2 divided by 4/9. So I'm going to use a little bit of estimation here first. I have one of each, so I know my answer is going to be negative. Now I can forget about that sign for a minute. I'm going to keep the first fraction, switch to multiplication, and flip 4/9 to 9/4. You might be looking and saying, oh, there's no opportunity to cross cancel here, or you might not even care about that. We'll deal with that in class. I'm just going to go straight across. 1 times 9 is 9. 2 times 4 is 8. That's improper. It's unacceptable. 8 goes into 9 once, and there's 1 left over, and I have the same denominator. So 1 and 1/8. And notice I predicted ahead of time it should be negative. I'm going to throw that negative sign on there. Just FYI, those are little things that lose you points on an assessment. If you had left it positive, it's wrong. So don't make those mistakes. Think back, double check. All right, so -1 and 1/8. All right, next example, -6/5 divided by a -1/2. Notice I have the same sign. Answer is going to be positive. All right, so I'm going to keep 6/5 the way it is. Switch to multiplication. Flip 1/2 to 2/1. Now I'm going to multiply straight across the top and straight across the bottom. 6 times 2 is 12. 5 times 1 is 5. Again, it's improper. I want a positive answer, so I don't need to put a positive sign. Just leave it. 5 goes into 12 twice, and since 5 times 2 is 10, that means there's 2 left over, and our denominator is still a 5. So 2 and 2/5. All right. -6/7 divided by a -3/7. Doesn't matter that they have the same denominator. It's really not important. What I do notice, though, is that I have the same sign, so my answer is going to be positive. Keep the first. Switch to multiply. Flip the second. Okay, I can't ignore the fact. Like, these two 7s should be blinking, like, or flashing at you. It's like highlighted. Do you see that they are the exact same number? They have a common factor of 7. Whenever I see identical numbers diagonal from each other, it helps to just cross them out. I'm going to solve this problem the long way and then go back and show you 2 shortcuts for those of you really good with your multiplication facts to just bust it out. All right, 6 times 7 is 42. 7 times 3 is 21. 42 21st. That's peculiar. How many times does 21 go into 42? Oh, it's exactly twice. And it's a positive too. So that's the answer, but I'm going to go back just because I have to. All right, like, I would look at this and say, oh, well, these 7s basically just cancel each other out. 7 goes into 7 once, and it goes into this 7 once, so those just become 1s. Notice that they have a common factor of 3. 3 goes into 3 once, 3 goes into 6 twice. Now look what you got. A 2 and a bunch of 1s. 2 times 1 is 2. 1 times 1 is 1. Oh yeah, that's still an answer of 2. Again, stop by our lunch once in a while to learn how to cross cancel. Alright, last example. 1/3 divided by a negative 2 2/3. Alright, this needs to become an improper fraction. I have a mixed number. I'm going to ignore that for a moment. This becomes 3 times 2 plus 2, all divided by 3. I know it's going to be negative, so I'll just put that out right ahead. 3 times 2 is 6, plus 2 more is 8 thirds. So what I really have in this problem is 1/3 divided by a negative 8 thirds. Alright, I'm going to keep, switch, flip. Do you see it? Do you see it, threes? You should. You should want those to just go away. And then look at, you're literally left with a 1 on top and a negative 8 on the bottom.
Solving without cross-canceling? Ain't nobody got time for that.
So you could just do that and you're left with 1 on top and a negative 8 on the bottom, or just a negative 1/8. Oops, I'm off the charts here. Alright. And you're done.